Hello, everyone. Welcome back to the Jurassic. We still have a few minutes to go before we start. We'll start at noon Stockholm time. If it's okay, I just wanted to test my audio setup. I would appreciate if I could get a shout out in the Twitch chat if I can be heard. Awesome. Thank you so much. So let me do a very quick uh, test to see that the presentation is working correctly. So I'm going to try and switch the view to it now. Okay, I can see it on the screen. Can everyone see the slides changing? Okay, I can see it on my preview also. Perfect. Okay, in that case, I will go grab my tea and I will see you all in 5 minutes. All right, it is noon on my timer, so I guess this is the time to start. Let me just switch the view to the presentation. Uh, First of all, it's great to see so many of you back. I hope you liked the last presentation. Just FYI, you don't need to have prior knowledge of the previous one. Those, even though it's part two, they are fairly independent, so you will be able to grasp everything that is here without having watched the previous one. So today's presentation's title is diversity because the time period in the Jurassic that we will be discussing is the period where most of the most famous groups of dinosaurs have emerged. These are their origins and where they are where they have originated. Yeah, I see that the title is wrong. It just shows how much of a noob I am, but I will make sure to correct it for the next time. Okay, so timeline. Last time we talked about the lower Jurassic, and we still have the middle and upper to discuss. Today, we won't talk about all of it. What we will discuss is the whole of middle Jurassic. And even though, just like the lower and upper Jurassic, middle Jurassic has subdivisions, we'll take it in its totality because those subdivisions are fairly short, and they are essentially the whole of middle Jurassic is about as long as just a single subdivision in the lower. So it's best to just talk about it as a whole slice of time. And we will also discuss the first age of the upper Jurassic period. So the Oxfordian is its name. We start with the middle Jurassic, that is about 11 million years of time. And looking at it, you can already see that this is kind of the dinosaur world image that we are used to. We have those big four-legged sauropods with long necks and medium-sized predatory two-legged theropod dinosaurs. And this is really where the dinosaur kingdom is already well underway, but still has ways to go. What we'll start with aren't actually dinosaurs, but they're close relatives, so crocodilomorphs. Crocodilomorphs are a super group of animals that crocodiles belong to, but also some of their close relatives. What we're looking at here is an animal called Lemmissuchus. Lemmissuchus belongs to a subgroup of crocodilomorphs. They are called Thalattosuchians. I talked about them briefly last time, but just as a reminder, they are fully aquatic crocodiles. Well, not full crocodiles, but fully aquatic crocodile relatives. We have marine crocodiles nowadays also. You can see some swim between the islands, but they are still semi-aquatic animals. Those things will develop fully aquatic lifestyle. Lemmissuchus is still a transitional form, so it still has normal legs, but you will see soon that will change. And very quickly about its name and size. So Lemmissuchus, pretty big animal named after Lemmy from Motorhead. There is actually here is a handy Venn diagram between paleontologists and Motorhead fans. Both like rocks. Lemmissuchus, both enjoy the classics. It is only logical that the animal will be called like that. But while Lemmissuchus is not a standard Thalattosuchian, Neptuni draco is. And you can see already here this is a fully aquatic animal. Those are flippers, not legs. There is a fin at the end of the tail. So this is the kind of crocodile relative that has transitioned into an aquatic lifestyle completely. Size-wise, it's about 4 meters long. So this is not the largest predator in the Jurassic. There are still pliosaurs and some other animals there. But it is still a pretty intimidating animal. And, just going back, what is interesting about them is that their niche is that they are very fast. So this body shape, very narrow snout, powerful tail, strong back flippers, it means that they have super high acceleration and they are very successful ambush predators. However, they are not apex predators of the Middle Jurassic. It is this animal, and you probably know it pretty well. It's probably one of the best known pliosaurs in the pop culture. This is Leopleurodon. And I want to tell you a few things about it, because I think there are lots of misunderstandings about what it is. So, first of all, The artists have a tendency to skin wrap the animals. It was actually a little chunkier. There was a little more body fat on it, so you can see here how it would have looked like if the image was a little more representative of it. And the second thing I want to address is this. So Pleurodon was heavily featured in the documentary series called Walking with Dinosaurs. It's a 90s classic, and you can see here it is represented as this massive animal lunging out of the water and grabbing a big dinosaur and dragging back underwater to eat it. That representation is not accurate. So the Pleurodon you see here is actually based on a real living animal that we'll be talking about in the future, but this is not actually how the animal looked like. The Pleurodon was actually significantly smaller. It was about 5 to 6 meters long. Now, this might not seem like that much, knowing some of the other animals, but when you put it side to side to this artist here that has actually recreated its head, I think you gain a little more respect for it. Those teeth are pretty big, and the head is big enough to essentially swallow a human whole. And Ofalov, yes, Charlie, this is indeed the Pleurodon from the unicorn animation. It had some other pop culture references. There is a book series about it called Kronos Rising. A very ambitious plot, Pleurodon versus Megalodon. If you guys want to read it, you can check it out. It also has a very successful marketing campaign that you can see here on the left, incentivizing pliosaur owners to hug their pliosaurs, which is something I do every day, honestly. And on the right is the reference to this YouTube video with the unicorns and the magical Pleurodon, which took the Charlie and the unicorns to the Candy Mountain. Free Zombie asked if their teeth would grow back if they fell out. I actually don't know. So this is, I'm afraid, not a question I will be able to give you answer to today. Here is one more picture of the animal getting a chin scratch from a human. So this should give you an idea of how big Pleurodon actually was in relation to us. There were other aquatic reptiles living in that time. So close relatives of pliosaurs are plesiosauroids. They both belong to the group called Plesiosauria. And those are those long-necked animals that you probably know also. Much smaller, about 3 meters long. They are not apex predators along the pliosaurs. They mostly eat fish, squids, animals like that. And here is some additional artwork of the animal. The one on the right is made by Gabriel Ugueto, one of my favorite paleo artists. And there was also this third group, third relative to the pliosaurs and plesiosauroids, so called Romaliosaurids. You might remember I talked about them 2 weeks ago. There are those jacks of all trades, and unfortunately, this is the end of them. So they were pretty prominent in the early Jurassic, but as we enter Middle Jurassic, their reign comes to an end and they die off, leaving only those long-necked plesiosauroids and short-necked but big-headed pliosaurs. Austrian Warlock asks, what is an apex predator? It means it sits at the top of the food chain, so it doesn't have natural predators in its environment. So if you were to draw an analogy, nowadays, you could say that a ferret is a predator, but it is not an apex predator because it has predators also, like wolves hunt ferrets, so they are apex predators in their environment. So we say goodbye to the Romaliosaurs, and we move to something else that is pretty interesting in the Middle Jurassic. Middle Jurassic is a home to one of the biggest fish ever. Lycictis is a pretty interesting case because when it was first discovered, it was actually suggested that it was bigger than whales. There were lots of individual bones found, and the initial estimates put it at like 30 meters long. There was a little bit of hype there. The arguments about its size actually earned it its second name, so Lycictis problematicus, that is the full species name. Realistically, it was about 60 meters long. So you can see it here compared to the blue whale and a different marine animal This is an ichthyosaur that lived in the Triassic. So as big as Ichthys was, it wasn't even the biggest prehistoric animal of the Mesozoic. So Shastasaurus, which you can see here, was actually bigger. Some might ask, okay, but was this Ichthys the biggest fish in that case? And the answer is, it is bigger than any fish we have living today, but it was not the biggest fish. Another famous fish that you probably heard about, so Megalodon, was actually a little bit bigger than its Ichthys. So it doesn't have that going for it either. So all those rumors about its size, a little bit overstated. I want to show you a few pictures of it, because I think the animal is really cool. It was mostly a filter feeder. You can see it here swimming next to some Thalatsukian. Here is a different reconstruction next to a person. So a pretty big animal still, about 60 meters long, 2-meter person next to it. Every single picture you see it in, it has this open, pogging mouth like this, just pogging all the time in every single rendition. I don't know why all artists have chosen to paint it like this, but no matter how differently it is represented, this is what we get. So just to sum up, it is not the largest fish, it is not the largest aquatic animal ever, but it is the largest aquatic animal of the Middle Jurassic, and it has this thing going for it. It is the most pogger of the pog fish. I think nothing else stands close. Other survivors still present in the Jurassic are ichthyosaurs, of course. One of them is Ophthalmosaurus. At this point, they've been kind of pushed away from their predatory niche. There are more. They don't live so much in deep water as more in those shallow seas where they hunt smaller animals like the squids and small fish. Size here, it's not the smallest animal, but it is prey to animals like Liopleurodon, for example. One of the more interesting ichthyosaurs living in this time is actually the smallest ichthyosaur that we know of. So the name is appropriate, Nanopterygius. You can see it here next to a cephalopod. 2.5 meters, still a little bigger than a man, but the smallest ichthyosaur that we know of. You can see here a very cool picture by Gabriel Gueto of a shoal of those animals just swimming in the shallow coastal waters. Speaking of aquatic animals, we also have to remember about cephalopods. So ammonites and their relatives are very prominent in the Jurassic. This is one of the better time periods for them. They get to grow pretty sizable, but they eat each other also. The external shell isn't always enough of a protection. So one of the predatory squids of this time is Megateuthis. Not a small animal, not huge. This isn't like the giant squid we have today. You can see its size on the left. Hello, Nico, and hello everyone else if I missed you in the chat. On the right, you see a little bit of a Cthulhu-esque picture. This is actually how ammonoids get born. Now, I want to focus on Megateuthis a little longer. Those squids actually have a shell also. This is an internal shell, so it is under this external layer of skin. And on the right, you can see a fossil. So Jake, I see you asked the question after I commented about it. They didn't lose their shell. That shell is still there. It is just covered by this external layer of skin. And that shell you can see fossilized on the right here. There are multiple animals that have died and their shells have fossilized. And what is cool about them is that this fossil is so abundant in the fossil record that it is actually legal to buy and sell it. So you don't actually have to turn it to a museum. And because it is so abundant, what we see is quite a few fossils fossilizing in something different than stone. Not all fossils turn to stone. Some turn to pyrite and some turn to opal. So you get lots of those internal backside shells of the squids turn into those things. And since they are so abundant, they actually get turned into jewelry. So I promise you dead squid as jewelry. This is it. So this is the backside of the squid fossilized into an opal and later worked into jewelry that you can buy online right now. If you want to look for it, the proper word is a belemnite. So just Google belemnite jewelry and you will find it. And there is a lot of it. And some of it is actually pretty freaking cool. And, you know, to me, nothing says I love you like a piece of dead squid ass. So Yeah, this is it. Moving on. So as you can see, there is actually a lot of different marine life in those Jurassic seas. Much more diversity than what we have today. Because what do we have when it comes to large aquatic animals? We have sharks and we have whales. Here we have pliosaurs, plesiosaurs. Sharks are also there. Thalattosuchians. Lots of those weird squids. We have those massive fish like ichthys. So this diversity is just huge, and the seas will never be as diverse as they are in the Jurassic. This is also the time where you can actually see ichthyosaurs and plesiosaurs living together, which won't always be the case, but that is a tale for the Cretaceous. Moving away from the seas to the semi-aquatic environments is this animal. This isn't a true mammal. This is a mammalia form. It's called Castorocauda. And you can look at it and think, is this related to a beaver? And well, since this is a mammal relative, the answer is yes, but it is not a close relative. So that flipper-like tail is a common adaptation that appears in the fossil record multiple times. It is just a very efficient adaptation for mammals and their relatives to evolve into. So while this animal probably has kind of a beaver-like lifestyle, we can only speculate about dam building. It is not a direct beaver ancestor. Here is its size, so about 40 centimeters long. Pretty cute animal, if you ask me. I see more they ask about giant turtles. There are turtles in the Jurassic, but the really big ones will be in the Cretaceous, so that will need to wait for a little longer. There are other mammalia forms, so again, not true mammals yet. So Pseudotribos is one of them. You can see the skull is just 2 centimeters long, so very small animal. Stereognathus, again, another mammalia form, still not a true mammal, very small animal living in the shadow of the dinosaurs. And moving from the small things to the very big ones, let's talk about sauropods. So the first one I want to mention is Spinophorosaurus, and it is a pretty interesting one. I want you to look at the end of its tail. What you see here are spikes. So I want you to do away with the idea that it's only the stegosaurs and ankylosaurs that have tail armaments. In the Jurassic, actually multiple sauropods have clubs or spikes at the end of their tails. Here you can see the skeleton with those bones sticking out of the tail. And it is not the only one that will have this adaptation. What you are looking at here is Omeiosaurus. Omeiosaurus belongs to the group of sauropods called Memenchisaurs. They are the ones that aren't the biggest, but have the longest neck in relation to their body. And some Omeiosaurs, because Omeiosaur is a genus, so a group of closely related species, some Omeiosaurs, as you can see here in this adaptation, if you look at the tip of the tail, there is a small club there. And it is indeed the case. The species of Omeiosaurus on the bottom right doesn't have this club. The one on the top left, living in that same area, has it. So this kind of armament was common in sauropods at this time also. There is one more Memenchisaurid that I want to bring up. Last time we talked about Silophysis buttholes, so this time I will just continue the theme. We have an animal called Analong. This is a Chinese name that means something else than what I have implied, but just FYI. Now, we have those very long-necked sauropods, and there are some other weird sauropods living here also. This is Atlasaurus, and let me just say right now, this isn't a wrongly reconstructed animal. It is not missing any neck vertebra. This is the kind of sauropod that lived in that time with a very different adaptation. You can see very long necks, but a short neck instead. So it would reach the same height as those Memenchisaurs, but the body plan is completely different. You can see its size compared to a human here, and a bit of a different picture here. And a young one, proportions look a little better here, but really short-necked sauropods are a thing. They lived here in the Middle Jurassic. Rhedosaurus, I will mention it very quickly because this is the earliest known Australian animal, Australian sauropod. What is interesting about it is because we have a foot and a footprint assigned to it, we actually know, thanks to it, how sauropods walked. So they were actually tiptoeing. They first put their toes on the ground and later the heel. even though we have so much diversity, we don't actually get new elements to this tree of Sauropodomorpha. So there isn't that much change in the Middle Jurassic yet. Now, let's talk about some others. In Middle Jurassic, ornithischians. So ornithischians are those weird plant-eating dinosaurs with beaks that take multiple different forms. So Manidens is one of the animals we know as heterodontosaurids. Those mostly two-legged ornithischians, pretty small, with quills in their back. So they are the hedgehog dinosaurs, and they were probably capable of climbing the trees a little bit. This is a bit speculative, but they do have the right body plan to be able to do it. Here is a picture of two more duking it out on a tree, and one more a little spookier, if you ask me. There are some other ornithischians living there, like Colindra dromeus. I will tell you where it belongs in the family tree in a moment. I just think those pictures are pretty cute. I just love those two-legged herbivorous dinosaurs. Here is one more visual representation of it. And what is more interesting is this one, Scolovosaurus. This might not look like much to you yet, but I will tell you whose ancestor this one is. So we'll look at the Ornithischia family tree now, and we have some additions here. So first, Colindra dromeus is the common ancestor of that bottom part of the tree, so Neornithischia. So on the top you have those armored ornithischians, and on the bottom you have a different part of the tree. Calavosaurus, which is a descendant of it, is a member of the tree called Ornithopoda. And Ornithopoda is a proper name for so-called duck-billed dinosaurs. So you can see Parasaurolophus, Hadrosaurs, all of them, they actually start in the Middle Jurassic, but Calavosaurus still has a long way to go until it gets to this body plan. Now, speaking of ornithischians, I want you to take a look at this animal and tell me, looking at its and all those bones, protrusions, and so on, which group of dinosaurs it belongs to. What famous dinosaur is it an ancestor of? There is a pop quiz here. I apologize. Yeah. Godzilla, of course it's Godzilla. Nico, you got it right. This is a Stegosaurian. Huangosaurus is the earliest Stegosaurian. So Stegosaurus will come a little later in the late Jurassic, but in the Middle Jurassic we have the first Stegosaurian. And when you look here on the right is Scelidosaurus, one of its ancestors. So you can see the body plan kind of sticks, but there is a little less armor and more spikes instead. So the evolution went in a bit of a different direction. But Stegosaurs start in the Middle Jurassic also. We will add them on the family tree here. So you can see Scelidosaurus in the Thyreophora group leading to the Stegosauria. And its sister group we'll talk about a little later. We also have pterosaurs, of course, like Fengguanopterus. It's a Chinese pterosaur flying in the Jurassic. Almost all of them are small and have long tails. This is the kind of body plan that you are probably used to at this point. One of the more interesting ones is Chinglongopterus. I really like it because it's really tiny. It's one of those smallest ones. It will probably make a great pet if you wanted to have something small but still intimidating. There are those like Clobiodon, Gianchangopterus. Lots of them have pretty big teeth, but relatively small body sizes. It starts getting more interesting with this one. This is called a Darwinopterus. You can see that the tail is a little weirder. There are those like bony protrusions that make it look a little bit like a saw. There is this crest on its head. Evolution is starting to experiment with the pterosaur body plan a little bit in the Middle Jurassic. Size-wise, this is also one of the small ones. Since this is about Darwin, we have a small bird for a size comparison next to it. And here are some extra pictures of it. The crest, the scientists aren't actually that sure about its shape. So on the left, you can see a different take on it. I'm sorry, I need just a moment to get a sip of water. Keon, yes, it is named after Charles Darwin, precisely. Now, Pterodactyls, you can see even more experimentation with that tail. I don't know if they used it as a weapon. I don't know if those protrusions were sharp or not, but this is how those tails looked like at the time. This one is a little bigger, not a threat to humans if we were to run into one, but it could probably scratch you a little bit. Pterosaurs are accompanied by some other animals in the air. Insects are flying, and there are of course gliding mammal ancestors. Still not true mammals though. So Myapatagium is a mammalia form that simply has those very close mammal-like characteristics, but didn't get to the true mammalian line yet. We also have theropods in the middle Jurassic, and those ones are pretty important. So Eustreptospondylus looks pretty vanilla, if you ask me. It's just a normal dinosaur. Uh, Here is its size, about 6 meters long. It's less important what it's like and how it behaves. It is probably not an apex predator. There are some bigger theropods in the middle Jurassic. We'll talk about them soon. What is important is the family it belongs to. They are called the megalosaurids. This is a short-lived family, but it is important for the history of paleontology, if not prehistory, because megalosaurids are named after the megalosaurus. A megalosaurus is actually the first dinosaur ever discovered. Maybe discovered is a bit of a strong of a word because we probably found dinosaur bones before, but this is the first ever dinosaur classified. And it is pretty big, as you can see here. Megalosaurus could get a little chunkier. It's still not as big as T-Rex, but that size is really starting to get there. It used to look very different when it was first discovered. This is its first rendition, present at Crystal Palace in the UK, and its body shape evolved along with our understanding of the field of paleontology. You can see how it was represented through the ages. And what is interesting is this 1960s rendition is actually more accurate than the 1990s. At least the body plan, the way it's more vertical, is more accurate than the more horizontal body posture of the 1990s. In reality, it looked probably something like this. This is an older picture by Mark Whitten. And here is one made by him also. Again, the same artist of Megalosaurus and its original conceived form. So you can see the difference in our understanding of how those animals looked like actually back in the day. What is a little sad is that this statue of the Megalosaurus in the Crystal Palace was damaged recently. But luckily, they gathered lots of money and the reconstruction is underway to restore it. I want to tell you very quickly about its discoverer. So William Buckland is a pretty interesting character because he was a priest who was also a paleontologist. He was actually struggling his whole life to balance his faith and the discoveries of ancient animals that were going against his belief tenets. He's actually the person to be credited for finding the oldest human remains in the UK. The problem is he actually thought it was the body of a dead prostitute, so he found it, he left it there, and he reported it to the police. And after it was re-examined later, it was discovered that this was actually an ancient prehistoric human. He's the person who coined the term coprolite, so it's thanks to him that we don't refer to dinosaur poop as dinosaur poop, but we actually have a scientific term. And he actually cooperated in the creation of this piece of art. So this is called Duria Antiquor. I mentioned it before. This is the first piece of paleo art ever created. He was also a strong supporter of the glaciation theory. So this is the guy who actually came up with the idea that we used to have those glaciation periods, those ice ages. Even though actually first he rejected the idea when it was floated to him. Later on, he was the one arguing for it the most. And his wife is also interesting because she's one of the first people who actually made scientific drawings of dinosaur bones. So this is the jaw of Megalosaurus. And even though he contributed so heavily to science, he actually remained a priest his whole life. So he didn't see a conflict between his faith and his scientific pursuits. And before we move on from Buckland and Megalosaurus, one more picture of it. This is my favorite art by Mark Whitten. So this is a Megalosaurus hunting a sauropod in the middle Jurassic. I think it's just a beautiful piece of art. And there are other megalosaurs. So megalosaurs are super abundant in the middle Jurassic. Venator is one of them. I won't be talking about it too much. Again, quite a sizable animal, looking pretty vanilla. If you were to ever describe a dinosaur as just looking as a dinosaur, you would probably mean they are a megalosaurid. There are other predatory dinosaurs in the Middle Jurassic also, however. I want you to look at this one, and I want you to try and guess again which animal, again a famous dinosaur, this one is an ancestor of. I'll give you a moment and we'll have a drink. Not Dilophosaur and not Velociraptor. It is the ancestor of Tyrannosaurus rex. So Proceratosaurus is the first tyrannosauroid. This is where their family tree begins. It will take a lot of time for Tyrannosaurs to get to this body size. So Proceratosaurus, there are a few of them. All of them have this weird crest on the top of their nose, and they are not apex predators of this era. Megalosaurs are much bigger, and so are Allosaurs, so they're kind of middle of the line predator. You can see them on the family tree here. This group, Proceratosauridae, is actually not the one that will lead directly to the T-Rex. They are the cousins of the T-Rex. It's this other group that will lead directly to it, but they are its earliest relatives in the mega group called Tyrannosauroidea. So that from now on, we will be talking more about tyrannosaurs. We have also something else, very quickly. I want to talk about insects. This one creeps me the hell out. That proboscis is just terrifying. I hate bugs with long sticky bits. But it's a good time to talk about pollination. And this is interesting because pollination is actually older than flowers. First pollination probably looked a little bit like that. So we had those weird protruding thingies on the plants that the insects would just stick their proboscis into and drink the nectar and pollen from them. But in the Middle Jurassic, we have what might or might not be the earliest flower. It is unclear whether that is actually it. You can see the fossil on the left here. It is a little difficult to deduce whether that is actually the early flower or not. You can see what might be petals here. It might be something else. You can see it reconstructed as a flower on the right, on the left as kind of a mossy thing element. I'm not good with plants, so I have no idea what it could actually be, but the earliest evidence for what could potentially be a flower comes from the Middle Jurassic. With that said, we are halfway through. This was the Middle Jurassic, and now we move to the good shit, to my favorite part of the Jurassic. So we are moving to the Upper Jurassic, and we start with the Oxfordian period. What you see in the background isn't a Stegosaurus. This is a different Stegosaurian, and we'll talk about it in a moment. But we'll start with something else, because I promised you today that we'll talk about the origins of birds, and it starts with this animal. It is called Anchiornis. What Anchiornis is a member of a group called Maniraptoriforms. You can see this close relationship to Tyrannosaurs. Actually, they both belong to the group Coelurosauria. So Tyrannosaurs branch out first, Maniraptoriforms a little later. And to talk about the origin of birds, we need better resolution. We need another tree. So we will zoom in on the Maniraptoriform tree. And you can see there is a lot that is going to be happening here. And the aviales, which are what we will be talking about, are on the bottom right here. For the record, we won't be going chronologically here. Maniraptoriform tree is full of gaps. There are lots of things that we are missing and lots of information that we are lacking. So I will be filling this tree very irregularly. It won't be going left to right, which is why we are starting on the bottom right. So aviales are the group of Maniraptoriforms that Anchiornis is a part of, and they will lead to modern birds. And here is this boy's picture. Now, I will show you a few pictures of it, and we'll talk about it in a little more detail in a moment. You will see here that lots of its renditions are in the same color, so black feathers and red coloring on the head. This is actually one of the very few rare instances where we have a fossil that is so well preserved that we can deduce color from it. So it was black with those red and white elements on its body. You can see a few pieces of art of art of it here, and it was a tiny animal. It was a very small dinosaur, which makes sense because the first birds would have to be small and light to fly. Here you can see a very cool picture next to a small girl who actually built this model of Anchiornis. And one more picture of it hunting for small fish in a river. And what Anchiornis is actually a animal that a whole group of dinosaurs was named after. So Anchiornithidae are a group of those early aviale dinosaurs. And another of them is Kai Hong. So this is a Chinese dinosaur that you saw at the beginning of this presentation in the initial art. Kai Hong is also one of those where we know what color it was, and it was actually iridescent. So it had black feathers that were reflecting a multitude of colors. It was a super colorful animal, even though it was technically blackish. Again, quite a small one. You can see a hand next to it here, a bit of a different interpretation on the bottom right. And because it's so colorful, there are actually members of the LGBTQ community that have adopted it as a symbol of it. You can see some badges like on the bottom left of it online. You can see a pretty cool art of it made on the top right. It is one of my favorite Jurassic dinosaurs. It's absolutely beautiful animal. But I don't like it as much as like this one. This is another Anchiornithid. It's called Sericornis, which I believe means silky bird when you translate it. And it is just amazing. I think this is a beautiful piece of art of it eating a small spider, really pretty animal. Again, very small one. All Anchiornithids are pretty small. The smallest one being Eosinopteryx. You can see it here, again, next to a mouse. There is some extra art of it, a little more on the creepy side of it, possibly walking around in the night and stalking some prey, probably some insects also. And one last that I want to show is Aurornis. So here it is next to Eosinopteryx. Again, a small animal. And this is one more picture before we move on. Now, looking at all those bird-like dinosaurs, you are probably asking yourselves a few questions, which is first, could they fly? If they couldn't, what would they need those wings for? Next question, they belong to the group called Avialae. Are all Avialae dinosaurs birds? They are cute. Where can I get one? Which is the question that I had when I saw Sericornis. Where is Archaeopteryx, which is the most famous bird-like dinosaur, or maybe early bird? Why didn't we mention it before? And for that record, to answer all those questions, we need to start with the question that's at the bottom, which is, what is a bird? And this is the question we try to answer next. You would not be surprised to know that there actually isn't a single definition. There are multiple ones, and one of them is actually more commonly adopted than the others. But I want to go through all four to give you an idea why this is the kind of way we have decided to classify birds as. So we'll start with definition 1. And in definition 1, all reptiles closer to modern birds than crocodiles are considered birds, which would mean that this whole right side of this tree, all dinosaurs, all pterosaurs, everything you see on the right would be considered a bird. And I think you can see where the problem is with that. Those are clearly not birds in the way that we understand. And in a more practical sense, this boundary chosen between crocodilian ancestors and dinosaur relatives is very arbitrary. There is no actual reason to choose that boundary to be there. So this definition is not adopted commonly. Second definition is connected more to actual physiology. So all archosaurs with feathers, right? Which would mean that essentially all the neotheropods that you see here would be considered birds. And there are a few issues with it, because first, feathers at first served more of a thermoregulation purpose. They weren't used for flight. So small dinosaurs had them, but bigger didn't, because a big body thermoregulates a little better. So why is an ancestor of a big dinosaur that is feathered considered a bird, but its descendant isn't because it lost feathers? This is a very arbitrary distinction that doesn't make much sense. And for the record, what is a feather? This discussion is a pretty fluid one also, because that whole evolutionary process of actually animals evolving through feathers is also quite complex. So we don't know what actually constitutes a feather in this early age. So this definition isn't a great fit also. Third definition, feathered dinosaurs that can fly. So this would be called this group Aviale, right? And there are a few problems with it. First, we know there are some aviales, and we know there are some birds that don't fly, right? We have them living today. They were living after the dinosaurs died out. And you can make an argument, yeah, but a group isn't really a physiology. It's more about the lineage. So even though those birds don't fly, they could be the birds because they are descendants from flying dinosaurs. But as it turns out, Anchiornis didn't fly. It was probably a glider. It was very early in the evolution of wings, and those wings you can see on the chart on the left. They are under the position A. This is the wing of an Anchiornis, and position C is the wing of a modern bird. So there is a big difference. They wouldn't have much of a lift power to keep the animal in the air. So in that sense, if aviales are to be considered feathered dinosaurs that can fly, but the very first aviale doesn't fly, that definition doesn't necessarily fit also. And so we arrive at definition 4, which is last common ancestor of all extant birds and its descendants. Extant means living, so not extinct, which would mean that all modern birds that we have today and everything in between them and their common ancestor. And this is considered a crown group, and this is in fact what we consider to be a true bird. Now, this is the definition that is most commonly accepted, and this is the one that we'll be going with when we ask ourselves a question of whether dinosaur X or Y is a bird. So, knowing this, let's go back to those questions. What is a bird? The common ancestor of all living birds and all its descendants. Could Anchiornis fly? Some of them maybe, but not all of them for sure. Anchiornis couldn't definitely. If in that case, what else were the wings good for? Well, they could help glide, and also they could help an animal climb. For example, when it was running from a predator up a hill, having wings to generate additional lift could have actually been helpful in helping it escape. They are cute. Where can I get one? And listen, there are lots of aviales in Stockholm. If you want to take some seagulls off our hands, I would really appreciate it. What about Archaeopteryx? Archaeopteryx comes later. It is actually a late Jurassic animal. So all those things you see here actually predated. So Archaeopteryx is no longer the earliest known bird ancestor in the sense that we have discussed here. And finally, the question. Knowing all this, are there true birds in the Jurassic? And the answer is no. There are no true birds. There is no common ancestor of all modern birds living in the Jurassic. That won't come until somewhere in the Cretaceous. There is a discussion of whether that is early or late Cretaceous. We'll talk about it in the future when we have a presentation about the Cretaceous. But all Jurassic dinosaurs are not true birds in the sense that they don't belong to the crown group. However, that doesn't take away from the coolness of the group. Aviales are here now, so Middle Jurassic has that going for it. You can see Archaeopteryx here. It will come in a later presentation. We won't be talking about it today. But going back to the Maniraptoriforms, even though birds don't fly, that doesn't mean other dinosaurs don't. And this is probably something that might seem a little weird because we know that the only flying dinosaurs were birds. But there are some others. And there is a group here called Scansoriopterygidae, which is a bit of a mouthful. And it is fucking cool. And the animal that belongs to it is my favorite Jurassic dinosaur. It is called Yi-Chi. And you can see it here. It looks like taken from a fucking D&D book. But it is a real animal. So it has membrane, bat-like wings. It has 4 tails. It has feathers. On top of that, it is an insect hunter that lived in the trees. And it was a true flyer. It was capable of powered flight. There were lots of experiments done with its skeleton and the models based on it. And the scientists have determined that yes, using the membrane instead of those not fully formed feathers would have allowed the animal to maintain a lift and powered flight. So while Scansoriopterygidae don't lead to birds, they were the first flying dinosaurs before birds were present. Here is a different interpretation of it, assuming that there were actually feathers covering this membrane. We aren't actually sure of it. Kion, I don't know. I was actually supposed to check what Yichi means exactly, but I forgot. If you want to Google it and write it in the chat now, that would be super awesome. This is a different picture of Yichi, and here is it's looking a little more intimidating, reeing at an insect sitting there on the branch next to it. There is also a theory that it could have used its wings for balance when running along branches in the trees where it probably lived. And here are some other really cool pictures of it. I just love this animal. It was probably capable of grasping tree branches and hanging upside down, kind of like bats, even though it wasn't in any way related to bats at all. There were some other kinds of pterygids living in the Oxfordian, like Ambopteryx that you see here. It looks just awesome, kind of like a dragon, if you ask me. Here are a few more pictures, one by my favorite artist, Gabriel Gueto, just amazing, amazing stuff. And here's one again, balancing on a tree branch running after an insect. And more of a cute rendition here. Yeah, so just beautiful, beautiful animals, and there were a lot of them living here in the middle Jurassic. They are a short-lived group, and they won't get very far, unfortunately. Size-wise, all very small animals. Now, gross alert. I will show you something a little gross, so if you are eating, just be warned. This is a flea. What was interesting is that with some fossils of Scansoriopterygids, there were found fleas living on dinosaurs, and this is Pseudopulex, and it's about 2 centimeters long, which, yeah, this is a big flea, and it might not seem that big until you realize this is the size of your eyeball. Right, so a human eyeball is about 2 centimeters wide, and you can see the comparison here. You would not want to catch an itch from one of those things. Now, speaking of Paniraptoriforms, there is one more group of them living here in the Middle Jurassic that I want to bring up. They are the coolest dinosaurs that you have never heard about. They are called Alvarezsauridae. And I promised you anteater dinosaurs, and this is them. And the comparison that would best explain their feeding behavior are eye-eyes. Eye-eyes are those weird mammals with very long fingers that they use to dig into holes left by insects in trees and dig insects out and eat them. And in fact, we see those kinds of adaptations in Haplocaerus also. Haplocaerus had this long finger, had the dentition that would make sense for an insect-feeding animal. And what is interesting is that Haplocaerus is a beginning of a line of dinosaurs that will be quite weird. First, they will be very small, up to your knee. And second, they will have only a single finger later on. So they will have a hand ending in a single claw and nothing else. That long, elongated finger will be all they will be using. So here is one more picture of this boy. And just to put it into context, on the Maniraptoriform tree, here are Scansoriopterygidae, so those bat-like dinosaurs, and Alvarezsaurids. And Alvarezsaurids are really cool, but this is one of the instances where you have a huge gap in the fossil record. It will take 60 million years until we find another one. So say goodbye to them because you won't hear about them again until we get to the Cretaceous. Moving on. There are other things flying in the late Jurassic also, in the Oxfordian, like the Nesodactylus, which is one of the Oxfordian pterosaurs. You can see it here, it's one of those dark ones feeding on a carcass of a pliosaur. We have Sordes, one of the cute ones. I think very small. You can see it here on the left examining a snail. Here is a size comparison so you get an idea of how big of an animal it actually was. And this is an important one. Rhamphorhynchus, a weird name, a bit difficult to remember, but quite an important one. After it is it's a name of a very big group of pterosaurs that are known from those small bodies and long tails. Rhamphorhynchoids were super abundant until this time. And almost all Jurassic pterosaurs were rhamphorhynchoids so far. Here are a few really cool pictures. I just love pictures, but Gabriel Ugueto, I think it looks super cute here. It was an aquatic, so not aquatic, it didn't swim, but it was a coastal pterosaur. It was eating fish. We actually found bones of fish in its body. It could get big, up to 2 meters wide wingspan, but there were some subspecies of Rhamphorhynchus that were quite smaller also. And here's one more cool picture of them just flying over the ocean. Now, I won't be going to the full pterosaur tree here. I think this is a little too much for this sort of presentation, but this is an important time. Oxfordian is the point where we start seeing some pterosaurs that look very different. So far, all of them were small with long tails, and now we get something a little different. You can see a shorter tail, a bigger head. This is the beginning of a group of pterosaurs called pterodactyloids. So pterodactylus that you all heard about, and all those pterosaurs with huge heads and massive body sizes, this is where their part of the family tree of the pterosaurs begins. And they will start pushing off the rhamphorhynchoid pterosaurs. Cryptodracon is one of the earliest pterodactyloids here. However, even though pterodactyloids are here, in the Oxfordian, it's actually the rhamphorhynchoids that are still the dominant type of the pterosaurs. So you can see one rhamphorhynchoid here having just hunted a cryptodracon. However, just as dinosaurs have those weird flying cousins, like the Yichi, pterosaurs have their weird ones also. They are called anurognathids, and they are my favorite pterosaurs. They are cute, short-faced, short-butt pterosaurs, very small, insect-eating. There is no beak in this case. They have just this weird, short mouth. Jeholopterus is one of them. You can see a few pictures of it here, just a flock of them on the left, hunting insects in the trees. And some extra art of it, because I think it's a incredibly photogenic animal that honestly has inspired a ton of art. You can see it's a pretty small one also. Here is a more of a colorful version. This is a different species, another anurognatid. They're the rhynchoids. I see you are all liking it. Yeah, so multiple art of those things. I will write down their name. Anurognathids is the name of the group. If you want to look for their art, you can use this to find them. And they probably also had whiskers, which just adds to the cuteness factor. And whiskers make sense because they were hunting at night, and long whiskers would help them identify their prey and adjust the movement of their head to catch insects in flight. Here are two very interesting pictures of it. They were so small they would probably fall into nets set by spiders. Here is a potential on the left is how a potential colony of an anurognathids could have looked like. So they're super cute. I just love them. And here's one size comparison to a modern cat. I don't know if it will actually clean itself the same way that cats do, but I like the image, so fuck it, it's going to be here. One of the more popular ones to get art is Batrachognathus. I think this is just beautiful art of it. You can see it kind of camouflaging on a tree trunk here on the left. Gabriel Ugueto on the right. Again, beautiful piece of art from him. Here is a wing spread out, and one sitting next to a more standard pterosaur. What you see on the bottom right is a pterosaur. This is not a bird, though it might look like a little bit at first. And on the top right, a real treat, one that is yawning. So super cute animals. One taking a chill in a sweater here, and on the left, a little bit of a funky one next to a cat. Just amazing animals, and I think you understand why they are my favorite type of a pterosaur. Now, let's talk about dinosaurs in the Oxfordian. We need to rush because we're running out of time again. So first, we have more of those sauropods with maces. This is a Shunosaurus that has just messed up a tree because it annoyed it for some reason. Shunosaurus is a sauropod with actually the largest mace that we know of. It was pretty big, a very intimidating animal. I think this piece of art is just amazing. It is not necessarily accurate, but it is super cute, and I just love it. And we have Mamenchisaurus. So the whole group of sauropods called Mamenchisaurids are named after this one. A pretty big animal. It's not as big as some others, but again, very long neck compared to the rest of the body. A mace at the end of the tail. Super intimidating animal. You can see a few Mamenchisaurus species sizes on the left here. A great picture on the top with a storm in the background. And the way Mamenchisaurus was portrayed in the Jurassic Park 2 movie. Actually, semi-accurate. They actually got pretty close with this one. Here is a skeleton. This is one of the smaller species, but a full skeleton, so I think it looks just amazing. And you can see here really how long that neck was compared to the rest of the body. And one more picture of the Mamenchisaurus. Now, I will try to pronounce this name properly. Vuivria. Vuivria. I'm so sorry. Listen, I actually practiced this name. Vuivria is a French sauropod, and Vuivria is a pretty important one. Yes, I promise you a baguette sauropod. This is it. So Vuivria is actually a first brachiosaur. We'll talk about them in a little more detail in a moment. You can see a body plan that you probably recognize from some other brachiosaurs that you know better from Jurassic Park and other pieces of pop culture. So let's take a look at where those sauropods belong on the tree. Shunosaurus is here at the very base of this split into those two groups. And Brachiosaurs are here. So Brachiosaurus is actually a descendant of Vuivria. And this is where their family, part of their family tree begins. Brachiosaurs belong to the Titanosauriforms group of sauropods. Let's talk very quickly about Stegosaurs living in the Oxfordian. Chunkingosaurus is there on the bottom left. This is one of the medium-sized stegosaurs fighting off an allosaurid called Yangchuanosaurus. Size-wise, Chunkingosaurus still not very big. Those aren't super huge animals. Stegosaurus will be much bigger than that. My favorite Stegosaurian in the Oxfordian is this one. Is Gigant Spinosaurus. I think I don't have to explain the name when you look at it. Those spikes are really massive. They're probably covered in keratin, so actually much bigger than what you see here on the skeleton. You can see how they would point backwards. Size-wise, not a very big animal, but those spikes would actually be very helpful in deterring predators because the animal couldn't be ambushed from the back. Trying to run into it from the back would have been very dangerous and potentially very lethal if a predator would have become impaled on those spikes. So a very cool stegosaurian animal, and there are more of them. This is the peak of the diversity for the stegosaurs. So the late Jurassic, there are tons of them, and there are some, these are just a few of them. Tian Yulong is a different ornithischian. This is a heterodontosaurid, super fuzzy boy. In those feathers, there is a ton of spikes. So this is one of those hedgehog-like animals. A small dinosaur, but not one you would like to grab in your hand because it would end very badly for you. Here is a different picture. And here, there are some predators that you can see. And there's a different ornithischian at the bottom there. Its name is Yinlong, so a Chinese animal hiding from the predators. Those are actually two takes on the same scene. The artist on the right recreated the one on the left. And this is a very important animal. I want you to take a closer look at it here and look at this small crest here. This is the beginning of the group of animals called the Ceratopsia. So you can see them here in the Ornithischia tree. And they will lead, of course, to the Triceratops. This is its earliest ancestor. Let me just say right now, it will take a long time until they get to this body size and this body plan. So they will for very long stay as a two-legged animals with those very small crests at the back of their heads. So you can see a few pictures of it here. Pretty cool looking animal, but it has a long way to go until it gets to this properly intimidating body plan with massive horns and a massive defensive frill. Very quickly about predators. This one that you saw here is Proceratosaur. So this is actually one of those early Tyrannosaur relatives. Guanlong is its name. You can see here this trademark crest on its head. And a few more cute pictures of it. And my favorite artist again, Gabriel Gueto. I think just an amazing art of this animal. There were, again, Allosauroids here, so very early Allosaur relatives. Not true Allosaurs, but more like common ancestor of all Allosaur groups. Size-wise, pretty big animal, pretty intimidating. There are other Allosauroids, like the Sinraptor. There are Megalosaurus, of course, in the Oxfordian. You can see it here, size-wise, Afrovenator. Here it's one wading through a river. And we have a new group, Eoabelisaurus. It belongs to the Ceratosauria. Now, I will put them all on the family tree. Abelisaurids are here. Those very short hands, not related to T-Rex, actually related to Carnosaurus, so a very horned, very intimidating animal. And what I want you to look at is how many groups of big predators are competing here. This will not happen again in the history of the dinosaurs. So the late Jurassic is the peak of diversity of big theropods. They are all competing for the top of the food chain position here. However, there are some smaller ones also, like Aorun. It's a pretty basic animal here, a bit bigger than a cat. Well, a little more than a bit. And what is more interesting is a different group of ceratosaurs called Noasaurids. I will tell you about them now. You can see them. First, Zhuang belongs here. So this is one of those common ancestors of Tyrannosaurs, Maniraptoriforms, and so on. And Limosaurus is a Noasaurid. And you might think, oh, is this one of those ostrich-like animals, right? Ostrich-like dinosaurs, like the Gallimimus. The answer is no. Those will come later. They will be members of the Maniraptoriform tree, but only in the Cretaceous. This is an instance of convergent evolution, and we have this body plan emerging in a different group of animals. So those are descendants of ceratosaurs. And what is interesting about them is that babies and adults actually have a different diet. Babies are predators, while adults are herbivores. This is the only instance that we know of in the dinosaur kingdom where the dentition changes this much and the dinosaurs change their diet so severely. In the late Jurassic, we also have this. This is pretty interesting because this is a fossil of a parasite on a larvae. Pretty interesting find, very rare. And of course, we have some aquatic animals like the Pliosaurus, Gallardosaurus that you saw previously. We have very few bones of it, so we don't know exactly how it looked like. And we finally get to the big Pliosaurus. This is Simolestes. It's about 7 meters long, not fully. But what is intimidating is not so much its size. So a few pictures to go through. I need to really rush now. It's its teeth. Here are some dinosaur teeth and the tooth of a Simolestes. So you can see this thing's bite would have been much worse than the T-Rex, for example, or the Spinosaurus that you probably heard about. There are other pliosaurids like this one that was probably a deep diver. Bones shown signs of decompression sickness. Here it is portrayed diving deep and feeding on the carcass of Litz ictis, and Litz ictis is still present at the end of the Jurassic. And my favorite plesiosauroid in the Oxfordian is this one, Statinectis. This is actually a short-necked, long-necked plesiosaur. I think it looks super cute. Again, art by Gabriel Gueto. We have long-necked ones also, like Morenosaurus, about 8 meters long. So they are starting to get a little bit bigger at this point. You can see here that the neck is actually very muscular. Lots of the old art of those things shows them as those very noodly snake-like necks, when in reality they were much thicker and much more muscular. So here is a few more pictures of it. And we have more Thalattosuchians. So those crocodile relatives here. Cricosaurus is one of them. This body plan that I told you about, almost like a torpedo, very small front limbs, big back flippers, strong tail. That would mean super strong acceleration. Here they are compared to Litz ictis, just size-wise. This is a different Thalattosuchian, about 3 meters long. So Litz ictis was a pretty big animal. and those not necessarily the biggest predators of its time. And of course, the seas are inhabited at this time still by lots of cephalopods, by ichthyosaurs. This one is interesting because it actually lived in the Arctic. So a pretty interesting ichthyosaur. And where we will end today is our ancestors, mammalia forms. So first is Rugosodon, a small animal, really. I'm bringing it up to show you a difference between it and the next one, because the next one is a true mammal. While we don't have true birds in the Jurassic, we do have true mammals. Juramaya is one of the earliest true mammals. It is the common ancestor of so-called therian mammals. So the ancestor of all marsupials and placental mammals. Placentals are us, marsupials are like kangaroos. This is not the common ancestor of all mammals because it doesn't include monotremes. That ancestor is probably somewhere in the middle Jurassic, but we didn't find it yet. So we have this gap in our knowledge of the fossil record. This is the size, so essentially the size of a mouse, but a pretty cute animal. And what is interesting about it is that it was actually featured in Animal Crossing. You can see it, you can dig it up, and you can find it in the museum in Animal Crossing if you are lucky enough to find its fossil. And this is where we end today. I apologize for going over time again, but I did better this time, just 5 minutes overtime this time. Thank you all for attending. And just very quickly about what to expect next time. We will be back in 2 weeks for Jurassic Part 3, the title Giants, because the next part of the Jurassic is the peak of their domination. So we'll be talking about why they got so big, how they feed, how they breathe, how they mate. All this stuff will be a part of the discussion. We'll be talking about more armored dinosaurs, more bigger and even meaner marine reptiles. We'll be talking about very big oysters, which is more interesting than it sounds like. Danger noodles, so we'll be talking about snakes, some more duck-billed dinosaurs. We'll be talking about supersonic sauropod tails. I won't tell you more about this yet. Dinosaur taxi, which is a thing. And I will show you some plushes and Abzu references, which are very cool and relevant to the late Jurassic. So, this is it for today. Now, if you have any questions, feel free to ask them again. I see one already. Isla Luca asks, which game has the best dinosaurs in terms of modeling and animation? So, Saurian has some very realistic depictions of the animals. They have actually recreated 2 ecosystems that are essentially, they don't mix dinosaurs from different time periods. So there is a proper late Cretaceous environment and late Jurassic environment. There are feathered dinosaurs with lots of details put into them. So if you are looking for accuracy, I would suggest you check out Saurian. I'm not seeing more questions at this point. We went over time again, and I know that everyone is rushing to get back to their work. So again, thank you all for coming for the next presentation. I hope you learned something interesting today. And of course, all those dinosaur and animal groups, we will continue talking about them in the next presentation. It won't be just about sauropods. So this is it for now. So I'll be signing off. Thanks again, and I hope to see you all in 2 weeks. Bye.